All right, we're looking at 0654 Winter 2019, paper 6-1. Question 6 is the second of the physics questions. We've got a setup here which should be familiar to you. You've got a power source, a voltmeter, and an ammeter, and a length here, okay? And basically you're going to move your point C along this resistance wire, okay? And it actually tells you the procedure here. We close the switch, place a sliding contact, a movable contact, which moves so that L is equal to 10. Okay, we're going to measure current, and we're going to measure potential difference, and then turn off the switch. All right, actually, all that stuff's not too crucial at this stage. What we need to be doing is doing a bit of reading. Now, this is where I probably would disagree a little bit with CIE, however, this is the way we're doing this. If you notice here, we've got a scale here which has divisions going up in 0.02. If you notice here, we've got 0 to 0.1, 5 divisions. So 1 division is 0.02 volts. Okay? Now, in my world, what I would do is I'd give my reading to the nearest division. Okay? Now, if you notice here, so if it was pointing at 0.2, I'd expect 0.20, 0.22, 0.24. This is where you've got a little bit of a trick, because clearly our arrow has been deliberately positioned to be between 0.30 and 0.32. Now, you might be wondering, okay, what do I do here? Okay, actually, it's quite insightful to have a look at the rest of the data in this case. Now, if you notice here, I'll just move the table down. This is on the next page. We've got values here, 0.62, okay, 1.20. We've also got a 0.91. And that suggests to you, yeah, that actually it's okay to go for measurements in between the two, as long as you are happy that it's directly halfway, okay. You've got 0.30, 0.32, which suggests that this thing is pointing at 0.31. Okay, so that's our first value on our table. Like I say, some people would disagree with that. They'd say, okay, you go to the nearest division. Some people allow the half division. In this case, it's been allowed. Really nice question in terms of getting all the marks, because it tells you what to do. You're firstly told to complete the column heading, inserting the unit for resistance. Well, we all know that unit for resistance are ohms. And then says calculate the resistance of the 10 centimeter length of wire and use the equation. You're given the equation, R equals to V over I. Okay, well, that 10 centimeter but is the bit that we put the data in for. Always the same value of current in this case. We've got 0.31 divided by 0.36. Probably should have written that down a little bit more. That comes out as 0.86, i.e. 0.9. If you notice here, I've kept this as 0.9 for consistency. Yeah, everything else here is to 1 decimal place. You would be perfectly fine putting in 0.86 if you liked. Okay, it wouldn't really help you very much when you're plotting the graph. Okay, last one, we're asked to then put in the missing value of the potential difference as well. Okay, our potential difference, well, if R is V over I, then V is equal to IR, Ver, okay, we've got to take our value of our current, 0.36, and the value of our resistance, multiply them together, and we get 1.51. Alright, now, we come to the graph. Again, this is a really nice question because it's all set up nicely. Okay, when you're doing your graph, the first thing that you need to be thinking about is your scale. Okay, have you chosen a scale that allows you to use over half of the paper? Well, in this paper we're going up in tens on the length. Okay, length goes on the x-axis. Okay, all right. They haven't actually told you that here. R is going on vertical, L is going on the horizontal. Okay, length goes up in tens, so you should see there it's nice and easy. 0 to 10, 10 to 20, 30, 40, 50. Okay, resistance slightly different. We want to decide our values. Look at the values you're starting with a 0.9, you're going up to 4.2. Okay, so there's a range there of 0 to 5. Okay, we are told in this graph, we're not always told that, to start from the origin. Okay, so we must start from 0. Well, 0 to 5, okay, 0, 1, 2, 3, 4, 5, magic. This is going to be really nice and simple for us to get our axes correct. We also need to remember our labels, okay? We need to remember our labels, and whenever we're doing that, we're putting in the units, not just the name. We then need to plot each of our points, okay, and hopefully you have no problem with this, okay? That would bring us to really the end of this question. You've got a nice set of points, okay? The next mark is going to be for our straight line, which comes later. Okay, we'll tell you what, why don't we do the straight line now? Now, this is where I want to kind of show you what you should be doing. When people do these kind of lines, they are very tempted to force it through the zero. It's clear that this is the kind of graph we're looking at. Okay, we're looking at directly proportional relationships. We're looking at the fact that as I double length, double resistance, we know that. However, please don't force through zero. If you don't get this through zero, that's fine. When you're trying to draw a straight line, what you're trying to do is make sure that there is a balance of points about the line. So if I've got one on the top of this side, I should expect to have one on the bottom. They don't all have to be on there. Alright, so I personally kind of happy with something like that. Okay, I'm trying to use my see-through ruler, okay, to make sure that my points are okay. Now if you look here, I've got one just above my line, I've got this one on the line, I've got this one just on the line, this one just below, this one just on. So I've got one above, one below, and the remainders are pretty much on the line. Okay, be thinking about that when you're doing your graph. We don't need to join them up individually, we just need to draw one straight line through there. That's what the command is in the next question. Okay, so we're looking to draw the best fit straight line, and again, the way that we're judging that best fit line is really the spread of the points about here. Okay, there shouldn't be 3 and 0. Yeah, you shouldn't have 3 points below the line and 0 points above. Yeah, if we've got 5 points, we're expecting maybe 1 above, 1 below, 3 on. 2 above, 2 below, 1 on. Maybe 2 and 3 if it's really hard for us to plot, but never anything really unbalanced. Last bit, I haven't actually done this bit yet, okay, because I wanted to look at my line first. We just have a quick look at my straight line. It's a pretty good one. And if you notice, actually, I managed to get mine through 0. I wasn't forcing it. I wasn't looking at 0 whilst I was doing my line. I just drew my line and it happened to come out that way. If that's what happens, brilliant. If it doesn't go through 0, it doesn't matter. And in fact, you will find sometimes we don't expect the line to go through 0. Okay? More often than that, your line will not go through 0. Okay. The student says the resistance of the wire is directly proportional to the length. State whether your graph agrees with this. Now, this depends on what you drew. If we go through the origin, then it supports it. Okay? If we go through the origin, then we support it. If it doesn't, then it's up to you to try and make an argument. Okay, so in the case that we go through 0, yeah, my graph agrees with the statement, agrees because it is a straight line through the origin. I.e., if length is 0, R is 0. If length doubles, R doubles. And that's what a straight line through the origin does. Okay, if not, you've got a slightly harder job. Okay, you could say disagrees because it doesn't pass through the origin. Now this is where you have to decide. This is really your decision to make, okay? And to be honest, anything's valid here. There's no right answer to this. If I found, for example, that my line didn't cross through 0 and actually it crossed at 0.1, okay? Now what you could say is, look, I'm very close to the origin. Yeah, it doesn't quite pass through the origin. However, it's very, very close. Yeah, so I'd be quite happy with you saying even though it doesn't pass through the origin, it's very close to the origin and therefore follows the rules of direct proportionality. It's up to you. The only thing is you must make a statement, okay? You can't make a contradictory statement. You must explain it. You must justify it, okay? So try with confidence, yeah, depending on what you've drawn in your graph. Okay, to improve our investigation, okay, nice and simple. Let me just look back at our graph here. We want to do the experiment more times, right? If you want to be more confident, you do it more times. You want to do it at intervals of 5, 15, 25, 30, 45, 35, 45, etc. Okay, so we really want to take more data for different L values. Okay, again, I really want to stress this because I think that one thing, I don't think these questions are particularly difficult. However, the mistake people make is they do things like they say, be more accurate, be more confident, be better at experiments. That is something you are not allowed to say. Okay, what you have to do is criticize the technique, the process, and how the student went about doing what they did. Alright, so in this case, it is about taking the data. Do not say use better equipment, don't say be better at science, because if that was possible, we'd all be wonderful. Alright?